Welcome dear student and Jai Swaminarayan. In the previous video, we were discussed the question answer given in the textbook page number 100 and the page number 102. Now in this video, we will discuss the other question answer given in the textbook. So dear student, let's start with the discussion of the answer of the question given in the page number 103. Right? In the page number 103, three questions are given to you. And out of these three questions, two questions are of the example. So dear student, let us discuss the answer of this question. Right? So on the page number 103, first question is that when will you say a body is in uniform acceleration and non-uniform acceleration? So when we can say that the body is moving in a uniform acceleration and the body is moving in a non-uniform acceleration. So here the definition of the uniform accelerated motion and the non-uniform accelerated motion. So when the acceleration is constant, the motion is said to be a uniform accelerated motion, and the acceleration of the body is keep changing. The motion is said to be a non-uniform accelerated motion. So answer of this question is a body is said to be in uniform acceleration if it travels in a straight line and its velocity decreases or increases or decreases by an equal amount in an equal interval of time. The body is said to be a uniform acceleration. Right? So when the body travels the in a straight line and the velocity is increases or decreases by an equal amount, right? So change in the velocity is constant in an equal interval of time. The motion is said to be a uniform accelerated motion, and in this type of the motion the acceleration remains constant, right? So dear student, understand what do you mean by the uniform acceleration. So if the velocity increases or decreases by an equal amount in an equal interval of time, the motion is said to be a uniform accelerated motion. Now reverse, exactly opposite of this, a body is said to be a non-uniform acceleration if the rate of change of velocity is not constant. We can write this: if the rate of change of velocity is not constant, the motion is said to be a non-uniform accelerated motion, and if the rate of change of velocity is constant, the motion is said to be a uniform accelerated motion. Right? Now question number 2 is a example type question. We already discussed the example in the previous video. Right? A bus decreases its speed from 80 kilometer per hour to 60 kilometer per hour in a 5 second. So speed of the bus is decreases from 80 kilometer per hour to the 60 kilometer per hour in a 5 second. Find the acceleration of the bus. So here dear student, the initial speed of the bus is given to you 80 kilometer per hour. So we write the initial speed of the bus u is equal to 80 kilometer per hour. Here we need to convert this kilometer per hour into the meter per second. So how we convert the kilometer per hour into the meter per second? By multiplying 5 by 18. So 80 multiplied by 5 by 18, we get the answer 22.22 meter per second. So 80 kilometer per hour, that is equal to the 22.22 meter per second. Now, the final speed of the bus, right? Final speed of the bus V is equal to 60 kilometer per hour. This will convert into the meter per second. So 60 multiplied by 5 by 18, we get the answer 16.66 meter per second. So dear student, here the initial speed of the bus is 22.22 meter per second. Final speed of the bus is 16.60 meter per second. So here the speed of the bus is reduces. So we get the acceleration negative. So time taken to decrease the speed, t is given to you 5 seconds here, right? So by the definition of the acceleration, a is equal to change in velocity divided by time. So the final velocity minus initial velocity divided by time t. So here the final velocity is 16.66 minus initial velocity is 22.22 divided by time given to you 5 seconds. If you calculate this, subtract this and divide by 5, we get the answer minus 1.11 meter per second square. Here the unit of the acceleration is meter per second square. So dear student, understand this example. Initial speed of the bus is given to you. Initial speed क्या है? 80 किलोमीटर पर आवर. So we write u is equal to 80 किलोमीटर पर आवर. क्या लिखा हमने? u is equal to 80 किलोमीटर पर आवर. और उसको हम मीटर पर सेकंड में कन्वर्ट करेंगे. कैसे मीटर पर सेकंड में कन्वर्ट करेंगे? मल्टीप्लाई बाय 5 बाय 18. वी गेट द आंसर 22.22 मीटर पर सेकंड. सो इनिशियल स्पीड मीटर पर सेकंड में क्या आई आपकी? 22.22 meter per second. What is the final speed? Final speed of the bus is a 60 kilometer per hour. Final speed क्या है? 60 kilometer per hour, right? So we need to convert this 60 kilometer per hour into the meter per second. 60 multiplied by 5 by 18, we get the answer 16.66 meter per second, right? Now एक्सेलरेशन की फॉर्मूला क्या है? एक्सेलरेशन ए इज इक्वल टू चेंज इन वेलोसिटी डिवाइड बाय टाइम. सो चेंज इन वेलोसिटी दैट मीन्स फाइनल वेलोसिटी माइनस इनिशियल वेलोसिटी डिवाइड बाय टाइम टी. सो हियर फाइनल वेलोसिटी क्या है? 16.66. सो वी पुट अ 16.66. इनिशियल वेलोसिटी क्या है? 22.22. सो वी पुट 22.22 डिवाइड बाय time given to you 5. So if you calculate this, we get the answer minus 1.112 meter per second square. So here initial speed ज़्यादा है and final speed क्या है? कम है. So acceleration क्या आएगा हमारा? नेगेटिव में आंसर आएगा. So it is called the deceleration also, retardation also, right? So now we discuss a third question on a page number 103, right? So third question, what is the third question? A train starting from a railway station and moving with the uniform acceleration attains a speed of the 40 kilometer per hour in a 10 minute. Find its acceleration, right? So here a train starting from railway station from rest condition, right? So what will be its initial speed or initial velocity of the train? So here the train is starting from the railway station. It's from the rest. So its initial velocity of the train we take a 0. So rest का मतलब है उसकी initial velocity क्या है? 0 है. Moving with the uniform acceleration attain a speed of the 40 kilometer per hour. So the final velocity of the train is given to you 40 kilometer per hour. So final velocity of the train is a 40 kilometer per hour. So we convert this 40 kilometer per hour into the meter per second. 40 multiplied by 5 by 18 is equal to 11.11 meter per second. If you multiply 14 multiply by 5, we get the 200, and if you divide 200 by 18, we get the 11.11 meter per second in a 10 minute. So time given to you, t is equal to 10 minute. So we need to convert this 10 minute into the second. 1 minute is equal to 60 second. So 10 minute is equal to 10 multiplied by 60, that is a 600 second. So by the definition of the acceleration, acceleration is equal to change in velocity divided by time. So final velocity minus initial velocity divided by time t. So here the final velocity is 11.11 minus initial velocity is 0 divided by 600. So we get the answer 0.0185 meter per second square. So here the initial velocity is 0 and the final velocity is 11.11 greater than the initial velocity. So the acceleration is a positive. So the acceleration of the train is 0.0185 meter per second square. So now dear student, we discuss the answer of the another questions given on a page number 107, right? So next questions given on the page number 107. There are 4 questions given on a page number 107. So let us discuss the answer of these 4 questions given in a page number 107. So question number 1 on a page number 107. What is the nature of the distance time graph for the uniform and non-uniform motion of the object? So draw the graph of the object distance time graph for the uniform motion and the non-uniform motion. So when the object is in the uniform motion, the distance time graph is a straight line with a slope. So the distance time graph for the uniform motion is a straight line like this. So we have to draw only this graph. So distance time graph is a straight line for the uniform motion, and for the uniform motion, when the motion is a non-uniform, the distance time graph is a not straight line. It can be a any curve, any type of the graph like this. The distance time graph is a curvature, or we can draw the graph random, right? For the non-uniform motion. So draw both the graph for the uniform motion and the non-uniform motion. For the uniform motion का ग्राफ कैसे होगा? डिस्टेंस टाइम ग्राफ यूनिफॉर्म मोशन का कैसा होगा? स्ट्रेट लाइन होगा, राइट? एंड नॉन यूनिफॉर्म मोशन का ग्राफ क्या होगा? लाइक दिस कर्वेचर ऑफ एनी टाइप ऑफ द कर्व. सो फर्स्ट आंसर ऑफ दिस फर्स्ट क्वेश्चन, द graph distance time graph for the uniform motion is a straight line, and distance time graph for the non-uniform motion is like this curvature, right? Now question number 2, what can you say about the motion of the object whose distance time graph is a straight line parallel to the time axis? So dear student, when the distance time graph is straight line parallel to the time axis, the body is said to be a rest. So if the distance time graph is a straight line parallel to the time axis like this, distance time graph is a parallel to the time axis, the body is said to be a rest or a stationary. So body motion में है नहीं, राइट? वो एक ही जगह पे रेस्ट कंडीशन में है एट दिस मच डिस्टेंस. नाउ क्वेश्चन नंबर 3, व्हाट कैन यू से about the motion of an object if its a speed time graph is a straight line parallel to the time axis? So here dear student, if the speed time graph is a straight line parallel to the time axis, what you can say about the motion of the object, right? So when the velocity time graph or we can say that the speed time graph is a straight line parallel to the time axis. The object is moving with the uniform speed, with the constant speed. So this type of the motion is known as the uniform motion, right? So now question number 4. What is the quantity which is measured by the area occupied below the velocity time graph? So area occupied below the velocity time graph, which quantity is measured? So you know that. So area below the velocity time graph gives the distance covered by the object. So if you know that, so in the properties of the velocity time graph, we already discussed these things. The area covered by the velocity time graph on the time axis give us the distance covered by the object and the magnitude of the displacement. So the distance covered by the object is measured by the area occupied below the velocity time graph. So dear student, understand about the all the 4 questions given on a page number 107, right? So I hope that you understand the answer of all the questions on the page number 103 and 107. Remaining question answer on the page number 109 we will discuss in a next video, right? Thank you very much for watching this video, and keep watching my video to understand all the question answer on a page number 109.